Hello everyone. So this is a video tutorial to help you perform better on your weekly quiz for this week. Our topic is probability, and I just need to let you know that since the quiz questions are being generated by the computer, even though everybody gets the same type of questions, everybody actually gets a different question, not the identical questions. So the questions you see here, you will see similar ones in your own quiz, but these numbers, for example, will probably be different. And also the order of the questions will be different. So the first question here might appear question number 6 in your own quiz. And again, the numbers are also going to be different. So the answers here are not going to be the correct answers for your own quiz. So after having said that, let's jump in, and I'm trying to keep this video to a minimum length. So that's why I'm not going to read each question. I'll just jump in. So it's better that you pause the video, read the question, and then launch it again. So here we go. The first question, when we have 5 codes belonging to 5 people, the desired situation here is actually 1, right? Because there's only one way to get these 5 codes to their actual owners. There's not a second way of doing that. And when we return them, what is the total number of different combinations that we can return these codes to their owners? So that would be NS. So imagine the first person comes in, you have 5 codes, so you just randomly pick one. So you have 5 choices to give to the first individual. And then the second individual comes in and you have 4 codes remain, so you can give them any one of those 4s. Third person, 3 choices. Fourth person, 2 choices. And the last person will get the last code, so that's just 1. So let me just make these smaller. So essentially, by the principles of counting, when you multiply these numbers, which I'll do that here, that's product, all of these multiplied, that's going to be 120. So the probability here would be 1 divided by 120. Which is, and you wanna add more decimals here, so the answer would be 0.00833. It wants 6 decimal places, so we want to go 1 more to make it 6. So that's question number 1. Let's go to number 2. So read the question. You'll see that the sample space is given. So all of these pairs of numbers, that's our sample space. So NS is automatically given. All you have to do is just count these pairs. And you'll see that there are 18 rows here and 2 columns. So all of these pairs, there are 36 of them. So that's 36 our sample space. What about the desired situations? So we want these pairs, the sum of these 2 numbers, to be divisible by 4. So you'll have to check each one, like 5 plus 5 is 10, and 10 is not divisible by 4, so you don't count this. 5 plus 6, 11, not divisible. 5 plus 7, 12, bingo, 12 is divisible by 4, so you count this. So that's 1. So you keep going like that. For example, you'll see 6 and 6, that's 12. 12 is divisible by 4, so that's 2. So you're going to go through every single one of these pairs, add them, and see if it's divisible by 4 or not. So if the answer is yes, you count those. And you'll see that when you go through all of them, there are just 9 pairs that their sum is divisible by 4. So then the probability is, obviously, NE divided by NS. So 9 divided by 36, which is 0.25. So they want the answer as a fraction, and 9 over 36 is simplified, or 0.25, that's like 1/4. So that's why we put 1 over 4. So moving on to question number 3. So in this question, there's an interesting thing. We have 3 coins and one of them has a head on both sides. So I put here coin 1, 2, 3. Let's just assume that coin 3 has a head on both sides. So that means when you flip coin 3, you always get a head, nothing else, no tails. But coin 1 and 2 are regular coins, so they can give you a head or a tail, right? So let's say when we flip all 3 of them, so coin 1 and 2 can both be heads, or they can both be tails. Coin 3 is always going to be heads. And coin 1 can be heads, coin 2 can be tails, or the other way around. Coin 1 can be tails and coin 2 can be heads. So this is, so each row here, what you see here, is the combination of all different possible outcomes. Because coin 3 doesn't make a difference. It's always going to be heads. So coin 1 and 2, they can be both heads, both tails, one head, one tail, but they can switch, right? 1 can be head, 2 can be tail, or the other way around. So we have, and coin 3 is always heads because both sides are heads. So we have 1, 2, 3, 4 possible outcomes. So our sample space is 4, right? Our sample space is 4 because there's 4 different combinations. And the question is asking the probability of obtaining less than 2 tails. So in which of these triplets, if I may, which of these triplets do you have less than 2 tails? So less than 2 tails meaning you have to have either 1 tail or no tail. So this one is okay. I'm going to put okay because it has no tail, so that's less than 1. This one has 2 tails, so it's not okay. This one has 1 tail, 2 heads, so it's okay because it's less than 2, right? And this one also has 1 tail, 2 heads, so that one is also okay because it's saying less than 2 tails. So other than this situation, all of the other 3 are fine. So the desired outcomes can be achieved in 3 different ways. Whoa. So then the probability would be SE over SN, so that's going to be 3 over 4. The question is already asking that in fraction format, so that you put 3 over 4, but as a decimal it's 0.75. Okay, number 4. So number 4 is a really nice question. So we have numbered balls from 1 through 25. And we're being asked to find the probability that the number drawn, so you draw 1 ball at a random, and we want it to be either even or a multiple of 9. So imagine there are numbers here, 1, 2, 3, 4, 5, all the way up to 25. So how many of them are even? So obviously it's 2, 4, 6, 8, 10, 12, and it goes on until 24. So 1 through 25, you have 12 even numbers. You can count them by hand. 2, 4, 6, 8, 10. You got to stop at 24, including 24, because the next one, 26, is not in this range. So 12 balls are exactly even numbered. What about multiple of 9? So that's like 9, 18, 27, 36. But our balls are only numbered from 1 through 25. So 9 is okay, 18 is okay, 27 is not okay because we're exceeding the range. So only 2 balls, 9 and 18, are multiples of 9. So, but these 2, even numbered balls and multiples of balls, their intersection is not an empty set, because a ball can be even and a multiple of 9. So how many balls are there like that? The multiple of 9s are 9 and 18, that's it. And 18 is an even number. So the intersection of these 2 is 1, which is 18. So I need to subtract that intersection from the sum here, because the ball numbered 18 is counted here in the even batch, and it's also counted here in the multiples of 9 batch. So the same ball is being counted twice. That's why I need to note that the intersection of these two is 1, and that needs to be subtracted. So here the desired the number of situations is the even balls plus the multiples of 9, and then minus the intersection. So that makes 14 minus 1, 13. And obviously that's NS actually, so that's N. How many total balls do we have? 25, so that's the sample space. So the probability would be 13 divided by 25, and that's 0.52. That goes here. Alright, number 5. So number 5 is pretty much the same. Again, we have the same balls numbered from 1 through 25. And we want to draw multiples of 12 or multiples of 4. So multiples of 12, so that's obviously 12, 24, 36, but I can't exceed 25, so it's only 2 balls, 12 and 24. Multiples of 4 would be 4, 8, 12, 16, 20, 24, so there's 6 of them. What about the intersection? Multiples of 12, which is 12 and 24, both of them are multiples of 4 at the same time. So they're being counted twice, so I need to exclude them. So then the NE here is 2 plus 6 minus 2. But in reality, since multiple of 12 is always a multiple of 4, I don't need to really figure out the multiples of 12, just look at the multiples of 4. So that's why this is equal to that, because the intersection includes that. And then SN is also 25, same balls. So then this would be 6 divided by 25, which is 0.24. Number 6. Number 6 is a trick question, so just be careful here. So E is the event, and E prime is the inverse of the event. So like if E is rolling a 2 when you roll a die, then E prime would be rolling anything but 2. So if the odds for, meaning odds in favor of E, equal to the odds against inverse or complement of E. So this is actually always true regardless of the probability, because odds for an event is always the same as odds against the opposite of that event. If it said the odds for E equal to the odds against E, not E prime, then this would have been true. The probability, because it's a 50-50 situation, it would have to be 1/2. So that's why this is a trick. The odds for E is always equal to the odds against E prime. So we say the statement is false because it doesn't have to be this probability. For E, odds for E is always equal to the odds against E prime, regardless of the value. So you would pick that one. So in this question, number 7, we're being asked in part A, the probability that the sum is less than 4 or greater than 10. So look at this distribution table. The sum is here. Less than 4 is only then it is when the sum is 2 or 3, less than 4. So it's only how many times? 10 and 30. So less than 4 would be 10 plus 30, which is 40. And then greater than 10, which is when it's 11 or 12, and that's 80 plus 70, so that's 150, 80 plus 70. So the desired situation is, and there's no intersection here, it can't be less than 4 and greater than 10 at the same time. So that would be 190. And the total situations are 1,000, so the answer would be 190 divided by 100,000, which is 0.19.